Thank you, Brittany. Thank you for arranging this webinar, and thank you everyone for attending this webinar. For some of you who do not know me, my name is Rohit Pardasani, and I am a full-time instructor with INE, and I have 5 CCIE route switch, security, voice service provider, and collaboration. So without wasting much time, we will quickly get started with the webinar where we would discuss path selection in BGP. Now, BGP is kind of different from IGP, where IGP has specific metrics for path selection. Like, for example, OSPF has cost, EIGRP has the K values, bandwidth delay, maybe RIP has hop counts. But BGP path selection is not specific to one metric. It is based on basically multiple attributes. So if you look at BGP, there are 2 kinds of neighborship, right? We have eBGP neighborship, we have iBGP neighborship, and you can receive routes from multiple neighbors. You could receive it from an iBGP or an eBGP. So how does BGP actually do path selection? As soon as BGP receives a route, let's say a router receives a route, it doesn't matter whether the route came from an iBGP neighbor or an eBGP neighbor. The first thing that a router would do or BGP would do is verify if the next hop is reachable. If the next hop is not reachable, then he would not even start the path selection or go through the attributes. He would not even start that because there's no point going through the list of attributes and doing a path selection because the next hop is not reachable. So technically, next hop is like right on top. So let's assume that the next hop was reachable. If the next hop was reachable, then how does BGP do path selection? Well, BGP has many attributes. Let me write it down. So we have many attributes in BGP. The first one is we have weight. So weight is the first one. It is, again, if you look at the attributes in BGP, it is categorized in well-known and optional. In well-known, we have mandatory versus discretionary, and then we have transitive and non-transitive. If you look at weight, weight is obviously optional because it's Cisco proprietary. It's not well-known. It would not work on Juniper. It is Cisco proprietary. So weight is the #1 attribute. So if the next hop is reachable, the first thing the router would compare that, okay, which path should I take? If I have more than 2 or 3 or 4 paths, BGP does not do load balancing by default. It only has 1 path. So it has to select 1 path out of the 2 or 3 or 4 paths that it has. It has to select 1 path. So the first thing he does is he would check the weight. Is the weight the same? So weight is not well known. It is optional. So optional. And it is non-transitive. So weight is something that I cannot configure weight and send it to you. So you can never send weight outbound to a neighbor. It's not going to work. Weight is locally configured on the router. What's better? Higher is better. So there are 2 default values for weight. Let me in fact write it down. So higher is better. And there are 2 default values. The first default value would be, let me in fact reduce this. All right, so the first default value is going to be 0 or 32768. Now, why would the weight be 0 or why would the weight be 32768? If you have locally advertised the route, let's say if on my router, I go and give a network statement to advertise a network or advertise a route. In that case, on my router, my weight would be by default 32768. But if I have learned the route from another neighbor through BGP, in that case, the weight would be 0. So 2 default values are there for weight. If you've learned the route through BGP, the weight is 0. If you have locally advertised that route, then on your router, the weight would be 32768. So higher is better. So it first compares the weight. If, let's say, we haven't changed the weight, we haven't changed anything using route maps, and let's assume that we were receiving the route from two neighbors. So basically, from both the neighbors, when I received the route, locally, I would set the weight as 0 because I have learned the route. Remember, weight is not something that the neighbor sends. It is local to the router. So because I've learned the route from a neighbor, I will locally set the weight to 0. So since both the paths have the same weight, it goes to the next criteria for BGP path selection. The next one is going to be local preference. So that's my next one, which is local preference. So is local preference optional or is it well-known? Local preference is a well-known attribute. So it is well-known. Is it mandatory or is it discretionary? Well, local preference is not mandatory. So it's not that it has to be present in the BGP update. It does not need to be present. But if it is present, or if somebody has configured it, in that case, every implementation of BGP would understand local preference. So because local preference is well known, so whether it's Cisco, non-Cisco, it doesn't matter. Every router would understand, every BGP implementation would understand local preference. So it's well known, but not mandatory. It is discretionary. And again, higher is better. So higher is better. And the default local preference is 100. Now, local preference is also non-transitive, which basically means that me as a router, I cannot send you, the eBGP neighbor, I cannot send you local preference. Local preference is non-transitive. You cannot send outbound to an eBGP neighbor. You can configure it inbound from an eBGP neighbor. You can do outbound, but outbound only to an iBGP neighbor. So it's only within the AS it becomes transitive, but across ASs, it is non-transitive. That's why local preference is considered as non-transitive. The whole definition of transitive means that it goes across multiple ASs. Local preference cannot be sent outbound to an eBGP neighbor. So that's the preference, default 100. If I haven't set that, if I haven't increased that or changed it, then by default from both the paths, when I receive the route, locally I would set that to 100. I haven't changed anything. If that's the same, it goes to the next criteria, which is going to be originated locally or locally originated. So this basically means that if you yourself have advertised that route. So since I have not advertised the route, then I have learned the route from a neighbor. It goes to the next criteria. What's next? The next is AS path. AS path is going to be the next BGP path selection attribute. As far as AS path is concerned, AS path is well known. Besides being well known, it is also mandatory, which means it must be present in the BGP update. It has to be present. Anytime a router or a BGP implementation, if you send me a route and the update does not contain AS path, I would discard the update because that update is not a valid update. It must be a valid packet or a valid update because AS path is a well-known mandatory attribute, which basically means that it must be present in the BGP update. Because it is well-known and mandatory, it is definitely transitive. So I can set AS path outbound to an eBGP neighbor or inbound from an eBGP neighbor. It doesn't matter. You cannot do outbound in iBGP because AS path does not get prepended within the AS. I mean, you could apply it, but then that's going to black hole your traffic. So AS path, well-known, mandatory. What's better? Shorter hops of AS is better. So higher is not better. Shorter is better. So shorter is better. And there's no default value for that. If that is the same, what's next? Next is the origin code. So origin is also well-known. It is well-known. It is mandatory, which means it must be present in the BGP update. Any well-known attribute, any mandatory attribute, any well-known mandatory, they are always transitive, which means I can do outbound, I can do inbound, doesn't matter. Again, here, I is better than your incomplete. I mean, EGP is something that you will not find anymore. So I'm just going to list two of them. So I is better than incomplete, which is question mark. So what is I? What is incomplete? If you've learned the route through BGP and that router who sent you the update, he has advertised the route through a network statement, then the origin code for that route would be IGP. And let's say if that router who's sending you the update, if he has maybe advertised the route in BGP using the redistribute statement, in that case, you would see the route, the origin code as incomplete. So I is better than incomplete. So if that is the same, it goes to next criteria, which is MED. MED is not well known. Again, optional. It is non-transitive. A lot of people have this misconception that MED is transitive because they think, okay, I can set MED and I can send it to an eBGP neighbor. So I'm sending it across the AS. But what's the definition of being transitive? The definition of being transitive is that it goes across multiple ASs. MED, if I send it to you, you would not send it to any other eBGP neighbor because MED is non-transitive. And what's better? Default metric is 0. So lower is better. And default is 0. If that is the same, I mean, MED kind of works differently because sometimes MED may be ignored depending on the neighbor AS, which maybe we can discuss if we have the time. But the sixth one is MED. If that is the same, it goes to path type. So path type, which is eBGP update or eBGP neighbor, eBGP preferred or iBGP. So eBGP is preferred over iBGP. If that's the same, the next one would be router ID. Router ID, lower is better. So lower is better, lower wins. So this is how my BGP would do a path selection. I mean, there is a little bit more after path type. There's like IGP cost to the next hop. There is oldest neighbor, but there's no path selection or there's no changes that I can do to that. I can't control which neighbor came up first. So that's why these are the main attributes which BGP uses, which I can change or manipulate to to make sure that my router takes the respective path that you desire. A quick, easy way to remember this would be through these things. It basically means we love oranges, as oranges mean pure refreshments. So you can just remember it that way, that we love oranges, as oranges mean pure refreshments. So this is how BGP would do a path selection. Now, to demonstrate BGP path selection, obviously this webinar is going to be hands-on, and you shouldn't take my word for it. We would actually look at the router and we will try and see how wait and local preference and AS path or origin or even med, how they work. So going back to my diagram, let me quickly show you that. So this is the topology that I would be using to demonstrate BGP. So what's in my control is AS100 is in my control. So I may be the administrator for AS100. AS300 is in my control, and AS200 is in my control. AS54, AS254, and again AS54. They are ISPs, and I don't control them. So I have no access to ISP routers. I only have access to routers, which is AS100, AS200, and AS300. BGP has been pre-configured. I didn't want to waste time on configuring BGP during this webinar, so I pre-configured my BGP neighborship. These red lines, they indicate my BGP neighborship. So if I look at router 7's perspective, let's in fact go there. If I go to router 7 and do a show IP BGP, I have some routes being learned from ISPs. I have some routes. Let's just take one route. Maybe we will take a route originating from AS54, which is here. So I will look at routes coming from the ISP on R7. So let's do a show IP BGP regex underscore $54. So this basically shows me all the routes which I'm getting from AS54. These are the list of routes that I'm getting from AS54. So if you see here, I have to reach, let's say, the first network, 28.119.16.0/24. I have two choices to reach that network. I could go to the ISP directly, or I could go through R3. Why R3? Because if you look at this diagram again, R7 could go down directly to the ISP, or he could transit from R3. From R3, he would go to R8, and from R8, he would go to AS54. So think of this as, let's say this was ISP AT&T, and this is also AT&T. So same ISPs across different locations. Okay, so R7 has different choices. He would either take this path, go to R3, from R3 go to R8, go to R8 to R10 to the internet, or he could go down directly. Which path is he choosing? Let's look at the table. So he is choosing the direct path to router 9 to the ISP. Why is that? Let's check. Did we configure wait? No. Default wait is 0. Why is it 0? Because the route is not locally originated. It is learned through BGP. Somebody else has advertised that route. So my wait is 0 for both the sides. If the wait is same, the next it compares is local preference. Did I configure local preference? No. So default is going to be 100. Next it goes to locally originated. Is this route locally originated? No. So it goes to the next criteria. What's that? AS path. If the AS path is the shorter hops of AS, right? So the first path, the top path, has one hop of an AS. So direct next hop of AS is 54. If he goes through R3, it is 2 hops of an AS. Remember, BGP is not a router by router routing protocol. It is an AS by AS routing protocol. So you never look at it like this. R7, first hop is R3, second hop is R8, and third hop is R10. No, that would be wrong. The first hop from R7 would be AS200, second hop is AS54. So based on AS path, R7 chooses the top path because it's shorter hops of AS. So this path selection happened based on AS path. Everything else before that was the same. I didn't configure that. So based on AS path, it did the path selection. So let's say if I want to change that, maybe I want R7 to transit AS200. I need that R7 should not go from this ISP. He should not go from here. Maybe I want him to go from here. Maybe I want that. So I could use wait to influence that. Let's try wait. And like I said, wait cannot be done outbound. I cannot go to R3 and send wait outbound to R7 because wait is non-transitive. It is local to the router. So I have to configure it locally on the router. So what I'm going to do is to demonstrate this, we will configure wait and we will influence just this one route. We will ensure that remaining routes don't get affected with my changes. So what I can do is I could use a route map to make changes to wait. I mean, I could do it globally also in BGP, but the problem with doing wait globally under BGP would be that it would affect all routes. So maybe I could go to router BGP 300, and maybe I could say neighbor 155.137.3 and say wait. So set the wait to 1000 or 100, whatever you want. Default is 0. If I do something like this, this will make the changes, but the problem in this would be that all traffic from R7 would go towards R3, all traffic. Now, if I wanted to just make changes to one specific route, then I can do that with access list, prefix list, called in a route map, make the changes, apply route map to a neighbor. Let's try that. So I'm going to go back outside and maybe create an access list. So access list 1, commit, match the route. Now your access list should be an exact match as per the routing table. My routing table has the route as a /24, which you can see here. So my access list should also be a /24. So 28.119.16.0.000.255. So I have an access list that matches that specific route. Next thing would be creating a route map. So again, if this was like an iOS XR, then there's no route map there. I would use a route policy, like an RPL. But concept is the same. So I have an access list and I have a route map. Let's say I'll name this as from R3 and commit sequence number 10 and match IP address 1. So sequence number 10 says, if the access list matches, what do you want to do? I want to change the weight to, let's say, 1. Or let's give a different value. Let's say 1000. I want to set the weight to 1000. Now, if I exit out at this point of time, the weight would change for that one specific route, but all the remaining routes from R3 would get filtered. So a route map has an implicit deny by default, which means remaining routes basically get filtered out. You don't want that. So I would have one more route map with the same name, but a higher sequence number, which says remaining routes, accept them, but don't make any changes. So permit means accept them, but don't make any changes. I'm not setting anything inside the route map. So if I look at my access list and I look at my route map from R3, this is what I configured. I made this access list that matches, set the weight to 1000, remaining routes, don't make any changes, but accept them. Next, I go back to my neighbor, router BGP 300, neighbor 155.137.3, which is R3. One thing to remember about BGP attributes, when you make changes to the attributes, all changes have to be applied in direction of control plane, not in direction of data plane. It's always in direction of control plane. So I am receiving the route from R3, right? R3 is not sending weight. R3 sends an update. When I receive the update, before I put that in the BGP table, check for route map. So I'm going to say route map, which is from R3 inbound. So when I receive the update from R3, check for this route map, and the route map would change the weight to 1000 for that one specific route, and then put in the BGP table. Once it goes in the BGP table, it then starts the path attribute selection. And this time he finds weight, which means that R7 should take the path through R3 instead of R9. Let's verify that. Show IP BGP regex underscore $54. So my weight hasn't applied yet. Again, it takes a bit of time for the changes to reflect, because again, BGP convergence is pretty slow, but you can do like a clear IP BGP star soft, maybe a soft in, soft out. Let's check. This time I see the weight. I see a weight. And if you notice, even though my hops of AS is higher than 54, it is now preferring to go through R3. It now prefers R3 as the best part. But remaining routes were not affected. No changes happened for the remaining routes. Only one specific route the changes happened for, because I set the weight. So weight, most influential attribute. Do you want to use them? No. I don't really see weight being used a lot. It's Cisco proprietary, but it's one of the most influential attribute because it's right on top. So this is weight. You can do it in two ways, use a route map or do it globally under the process. Obviously, a route map is a better way of doing it because then you can match a specific route or a specific AS. All right, so this was weight. Let's move to the next attribute, which is basically local preference. So let's go to demonstrate local preference. Let's look at AS100. If you remember, I told you that local preference again is non-transitive. You cannot do outbound to an eBGP neighbor local preference. You can do outbound within to your iBGP neighbor, but you cannot do outbound to an eBGP neighbor. So let's look at from perspective of AS100. And again, going to, let's say, a route, let's say AS100 needs to get to routes originating from AS254. Let's assume that. And let's pick one route. Let's go back here and look at a specific route for 254. Let's just pick one, maybe this one, 51, 51, 51, 51. So how do you think AS 100 would, which path would AS 100 take to reach 51, which is here, 51, 51, 51. Now, I'm going to give you exactly 10 seconds to think about it. Look at the BGP, look at this diagram, and look at the BGP neighborship. I haven't configured anything, no path selection attributes. Think about how will R1 route, how will R4 route, and how will R6 route? AS100 basically, to reach that one specific network. So 10 seconds. Okay, so based on this diagram, R1 should route in this direction. R4 should route in this direction. And R6, this is eBGP neighbor, this is iBGP neighbor. R6 would prefer iBGP over eBGP, so he would route in this direction. Now, why is that? Let's look at R1 first. Did I configure wait? No. So default wait, he has three choices, right? He could go directly to R3 to reach this 51, or he could go to R4, or he could go through R6. He has three choices, three neighbors. I haven't configured wait, so default is 0. I haven't configured local preference, so default is 100. Hops of AS. If he goes from R3, the first hop is AS200, second hop is AS254, so 2 hops. If he goes from R4, first hop is AS200, second hop is AS54, 2 hops again. If he goes from R6, then first hop is AS300, then 200, then 254, 3 hops. So through R6 is eliminated. Now I have 2 choices, either going to R3 or going to R4. They both have the same number of hops of AS, 2 hops. So it goes to next criteria. Origin code. I haven't changed origin code. So if the ISP is sending incomplete, it would be incomplete everywhere. If the ISP is sending IGP I, it would be I everywhere. I haven't changed that. So it goes to next criteria. The next is Med. Have I configured Med on R3 and R5? No. So default is 0. It goes to next criteria. eBGP path type. eBGP preferred over iBGP. This is an eBGP neighbor versus R4 is an iBGP neighbor. R6 is gone. It's eliminated. But R1 has 2 choices now, 3 or 4. 3 is an eBGP neighbor, 4 is an iBGP neighbor. So obviously he would prefer R3 because of eBGP preferred over iBGP. So here the deciding factor for R1 was eBGP preferred over iBGP. For R4, he selects R5, again for the same reason. Your eBGP preferred over iBGP. But for R6, he chooses R1, even though R1 is iBGP and R7 is eBGP, because R6, the deciding factor was AS path attribute. Because if he goes from R1, it's 2 hops of AS. If he goes from R7, it's 3 hops of AS. So deciding factor was AS path. Let's quickly verify that. So if I go back to router 6, or let's look at router 1 first. So router 1, show IP BGP, regex, underscore 54 $. I am going to R3, okay? Because eBGP was preferred over iBGP. If I look at R4, R4 goes to R5. Again, eBGP preferred over iBGP. If I look at R6, he goes to R1, which you can see here. iBGP is preferred over eBGP. Why? Because of shorter hops of AS versus longer hops of AS. Okay? So this time, let's do some path manipulation. What we will do is, let's assume that we want that the entire AS, so this entire AS, to reach that 51 network, it should go in this direction. So basically my requirement is R1 should go here, R4 should go here, and R6 should go here. So the entire AS should exit through R6 to reach that 51. And if you remember, I told you that weight is locally significant, but local preference is not locally significant. It is significant within the AS. It is transitive within the AS, but it's still considered non-transitive because you cannot send it across ASs. So if I go to R6 and let's say I configure local preference with a higher value, default is 100. Let's say if I set this to 101. In that case, R1 would choose R6 and R4 would choose R1. Let's see that. So I will go back to router 6 and let's create an access list. I could use a prefix list also to match a specific route. So maybe I can use a prefix list, but you can use access list, prefix list, whatever you want. Or you can even match an interface if it is a locally, if it's a local interface. So maybe I can use the prefix list by saying IP prefix list, let's say network 51, and say 51, 51, 51, 51. Or in fact, I should say permit. Permit 51/32. Then create a route map. So let's say from R7. So from R7, permit sequence number 10, and say match IP address, prefix list, the prefix list name. If that matches, what do I want? I want to change the local preference. So set local preference to 101. Now again, local preference could be set globally also, lightweight. I could set local preference globally under BGP, but that's going to affect all routes or all traffic. So for all destinations, then R1 and R4 would transit through R6. So again, it all depends on what's your requirement, whether it's a lab environment requirement or lab exam requirement or production. It all depends on what you need. So if you want all traffic going through R6, then yeah, I could just set a local preference globally under the BGP process, and that would affect all traffic. So once I've done the route map, let's add one more line, 10,000, so that remaining traffic does not get dropped. So I'll show you my IP prefix and route map. This is what I configured. So I have a route map, sequence number 10, which says if the prefix list matches, set the local preference to 101. Remaining routes, don't filter, accept them, no changes. Let's go back to router BGP, I believe it's 100. And I just want to show you, I think it's BGP default local preference. So this is how you would set globally if you want to set the local preference. I don't want to do this. So I'm going to go back to my BGP neighbor and say neighbor 155.167.7, which is R7. When I receive the route from R7, remember, I'm not setting local preference outbound. I'm just saying that when R7, the eBGP neighbor, when he sends me routes, check for a route map. What does a route map do? The route map would be from R7 inbound. So check for route map. So route map will say, if he's sending you the 51 network, then change the local preference to 101. Remaining routes, just accept them, don't make changes. The effect of this, let's do a clear IP BGP star soft and do a show IP BGP. The effect of this, regex underscore 254 $. To reach 51, he is going to R7. But remaining routes, they are still going to router 1. But for 51, he is going to R7 in spite of higher hops of AS because I have configured local preference. And if I now check R1 by doing a show IP BGP regex, R1 goes to R6. If I look at R4, R4 goes to R1 because of local preference, which you can see here. So local preference can go outbound, but just within the AS, but not across ASs. So I personally prefer to apply local preference when I receive from a neighbor, like how I just did, rather than applying it outbound to an iBGP neighbor. Because imagine if I have hundreds of iBGP neighbors, then I have to apply it to all those 100 neighbors so that there would be 100 commands, unless I have like peer groups or templates configured. Then it's not a problem. But I prefer to apply it inbound. So when I get the update, make the changes, put that in the BGP table, and then run the path selection attributes, which makes them select R7 now, which I have configured local preference for. So with this, we've done the second attribute, which was local preference. I believe the third one was AS path. AS path, so again, locally originated, I can't do anything with that. So I'll move on to the fourth one, which was AS path. AS path, shorter hops of AS was better, right? So again, let's just pick one specific network. So again, let's say if I want that AS 100 to get to maybe this network, 192.10.10, which is here. So let's go back here. AS 100 to reach 192.10.10/24, which is belonging to AS 254. Again, by default, they would be going like this. And this guy goes here because of AS path. Assumingly, we want that this router or this AS transits in this direction. And we don't want to use local preference. Let's use AS path to achieve this. Now you remember I told you AS path was well-known, mandatory, which means it is transitive. So AS path is something that I can send outbound also to an eBGP neighbor. Let's try this. So to achieve this, what I will do is I will configure R3 to send AS path to this neighbor to increase the amount of hops. And I will configure R5 to send higher hops to R4. So both 3 and 5 would send higher hops of AS to router 1 and router 4. In that case, the path through R6 would be a shorter path, shorter hops of AS. And automatically, my path would change based on my configuration. Let's see that. So let's go to router 1 right now. If you see right now, he is going to R3 directly. R4 is going to R5, and R6 is going to R1 as of right now. So if I go to router 3, And let's say I create an access list, permit, I match the route 192.10.10.000.255, create a route map. Let's name this to router 1, permit sequence number 10, and match IP address 1, set AS path prepend, and now I have some choices. I could say last AS, so prepend the last known AS, or I could just give my own AS path. I'll just say last AS. And how many times do you want to prepend that? Let's say 5 times. Remaining routes should not get filtered, so permit 10,000. And then router BGP 200, neighbor 155.113.1 route map to R1 outbound. So I applied this outbound to my neighbor. The effect of this would be R1 will change its path. But before I do that, let me do R5 also. So access list 1, commit, I think it was 192.10.10.000.255. I have a route map to R4, commit 10, match IP address 1, and set AS path prepend, last AS 5 times. Remaining routes, accept them or send them with no changes. Router BGP 200. And neighbor 155.1, I think it's 45.4 route map. I don't see a route map here. Okay, let's do show run section router BGP. Well, I have address family activated, so I have to do this under address family. So address family, neighbor 155.145.4 route map to R4 out. The reason I have to do this because I have said no BGP default IPv4 unicast, which means address family gets created, and now I have to manually activate. Versus if you look at our tree, in our tree's BGP configuration, I did not do address family based configuration. It was all under BGP, and the default is IPv4 unicast is activated by default. So I had disabled that on R5. That's why I have to go under address family and apply the route map. So once I've applied that, let's save this. Let's look at R1 now. If I look at R1, I see how many times? I see 254, 1, 2, 3, 4, 5. I see 5 times. What was original? Original was 200 space 254, so 2 hops. Now I see 200, then 5 times 254 was added, and this was the original 254. So the original 2 hops are kept the same. I add 254 5 more times, which basically means now R1 chooses R6 for that one specific route. R4 would choose R1 for that one specific route because of shorter hops of AS, and R6 would prefer R7 because of shorter hops of AS. So you see, I can do AS path. I can do AS path prepend for path selection in BGP. It is pretty influential because it's well-known, mandatory, and it's transitive. So it kind of affects every downstream or upstream ASs. And let's look at the next attribute. The next one was the origin code. So let's select another route for doing origin. Let's look at this one, 205.90.31.1 0. So for this route, ISP himself is sending incomplete. So he is sending incomplete. And maybe we want traffic. Let's look at the diagram. Again, my traffic would be going by default in this direction. And let's say we want that all traffic should transit through R1. So basically, this guy goes here, he goes here, and router 1 goes here. Now, what's better in origin? If you remember, better in origin was I was preferred or incomplete. What is the ISP sending you? Incomplete, right? So if R3 advertises to R1 as an I, in that case, R6 was anyway going through R1 because of shorter hops of AS. But R4 was preferring R5 because of eBGP. But now if R1 gets an I from here, he will send an update to R4 with an I, which means now origin comes before eBGP preferred over iBGP. So R4 now gets an I from R1 versus incomplete from R5. Automatically R4 would choose R1. Let's see that. It's pretty straightforward. Now again, I already have a route map on R3, so I should not remove that because then again, it beats the purpose because you can have multiple matches in a route map. So all I can do is create a new access list. Let's say access list 2, permit, match the route, which I believe was 205.90.31.0. So 205.90.31.0.000.255. Go back to my route map, which was 2R1, permit sequence number 20, and say match IP address 2, set origin to IGP, which is I. I don't have to apply this route map. It's already applied from the previous task when we did AS path prepending. All I did was I added a new sequence number, which is sequence number 20, which says if this route matches, change the origin code from incomplete to IGP. The effect of this, if I look at R1 now, for 205, he should get an I. This should change to I. So maybe we can do a clear, it just changed to I. So R1 is going to R3. R6 also sees I, so he goes to R1. And if I look at R4, R4 had two choices from R5, which is eBGP, versus R1, which is iBGP, but R1 is sending an I versus R5 sending incomplete. So you see, origin can be used for path selection. Again, IGP is better than incomplete. The next one is going to be med. Now, med is the last attribute. I mean, we cannot do EB. I could do router ID. I could change the router ID to maybe do a path selection because lower is better. But I can't do much with eBGP being preferred or iBGP. I can't change that. But med is something that we can test. So again, let's look at one network. Let's in fact make this a bit interesting. You remember I said that med kind of works a bit different. So let's look at a route. Let me look at the diagram once. I'm going to go back to R6 and do a show IP BGP regex 254 $. Okay, I have these choices, right? Okay. So let's look at this one network, which is 222.22.2.0. Again, how's the traffic going by default? By default, R1 goes downstream, R4 goes to R5, R6 goes to R1. This is what is happening by default without any changes. R1 goes to R3 because of eBGP preferred over iBGP. R4 goes to R5 for the same reason. R6 goes to R1 because of AS path attribute. So if we want that R1 and R4, they should not go downstream. What they should do is they should go here, and R1 should go here, and maybe R6 should go here. For which route? Let's take a route which is common. So let's take a route from 54 AS. Let me look at the route. So AS path 54. Let's take the route 116.0.0.0. So for 116, default path is this. This guy goes here, he goes here, he goes here. This is default without any changes. We want that R1 should go here, R4 should go here, and R6 goes here. So let's try that. I will configure med. Let's do med on R3 and R5, and they will send a higher metric to R1 and R4. Okay, they send a higher metric. Default is 0, right? So I'm going to increase the metric so that R1 chooses R6, correct? Let's see if that happens. So going back to R3, let's create a new access list. Access list, let's say free commit, what was it, 116.0.0.0, 0.255.255.255. I go back to my route map to router 1, permit sequence number 30, match IP address 3, and set the metric to, let's say, 150. I'm just setting a metric. It's a random value. Let's do the same thing on R5. So access list 3, route map, I believe we had a route map, commit sequence number 30, match IP address 3, set metric 150. Okay, I've set the metric. So both R3 and R5, they are sending a metric of 150 to R1 and R4 respectively. If I look at R1 now, show IP BGP regex $54 for 116, the metric through R3 is 150, correct? The metric through R3. It is going through R4, not R6. But let me do a show IP BGP again. It is now going back to R3. Why? Because earlier the convergence of BGP is really slow. When I configured R5 to send metric to R4, R4 hadn't received the metric because you can see a metric is 0. But now R4 also receives metric of 150 from R5, and R4 sends it down to R1 as 150. So this is 150, this is 150, and R6 is 0. But he's still preferring R3. Why is that? Shouldn't med lower is better, right? Med should work. But med did not work. It got skipped. the med path attribute got skipped. It ignored the med and went to the next attribute, which was path type eBGP preferred over iBGP. Why is that? There's a reason for that. So let's look at these three routes, okay? So R1 has three choices to reach that one specific network, 116.0.0.0. He has three choices. But why is he ignoring med? Now, if you look at these three choices, whichever choice is on top, so this is the top one, this is the middle one, this is the bottom one. Whichever is the oldest neighbor, so whichever neighbor came up first would be the oldest neighbor. The oldest neighbor is always put at the bottom, and the newest neighbor is put on the top. So when R6 is the newest neighbor, because maybe when the neighborship formed, R6 must have, the neighborship must have formed last. Because he formed last, he's the newest neighbor. So the update from that newest neighbor is always put on top, number one. This is the second newest, this is the oldest neighbor. That's the order. Now, how BGP compares the attributes is going to be, if all your previous attributes are the same, like your local preference, weight, and let's say it reaches med, how does BGP do path selection in med? The first thing he will do is he will compare the first and the second. So the newest neighbor would be compared with the second newest neighbor. Now here, the newest neighbor has a med of 0, and the second neighbor has a med of 150. But med would be ignored because default rule states that med can only be compared if the neighbor AS is the same. What's the neighbor AS? 300. What's the neighbor AS here? 200. Since the neighbor AS is different, med cannot be compared. Ignores med. It goes to next criteria. What is the next criteria? eBGP preferred over iBGP. They both are iBGP neighbors. So it goes to next criteria. What's that? Lower router ID. R4 has a lower router ID than R6. So entry number 2, which is the middle one, wins. Now entry number 2 would be compared with entry number 3. Here, they both have a med of 150. But can med be compared? What's the neighbor AS? They both are 200. So med can be compared. But they both have the same med, 150. In that case, it goes to next criteria. What's the next one? eBGP preferred over iBGP. So this route wins and goes in the routing table. So that's the reason why the path is going to R3 in spite of R6 having a lower metric. So if you want R1 to choose R6, then there's one command that you need to do, which is going to be BGP Always Compare Med, which is off or turned off by default. So it only compares the med if the neighbor AS is the same. If the neighbor AS is not the same, then he would not compare the med. He ignores that. But the path selection in med is always top down. So newest to oldest, which means the oldest route will always be compared with the winner of these two routes. So first, it will always do path selection between the first two routes, first two neighbors. Whichever wins between them, it then compares that with the oldest neighbor. And then whichever wins between them, that goes in the routing table. So med is kind of tricky. It's not pretty straightforward. It may be compared, it may not, depending on the neighbor AS. If the neighbor AS is same, it will compare. If the neighbor AS is different, it would not compare. So in my case, if I go now to router BGP, 100 and say neighbor, or in fact, it's a global command, it's not a neighbor command. BGP always compare med. If I give this command and look at show IP BGP regex 254, this time for 116, it should prefer R6. Let's check. So now if I see, he's preferring R6, not R4, not R3. He's preferring R6. Same thing if I look at R4 now, show IP BGP, regex 254. Right now, R4 has only two choices, either going to R1 or R5, depending on my neighbor diagram. If you look at my neighbor diagram, he only has two choices, either going to R1 or going to R5. Which one is he choosing? He is choosing R5. Why is that? In spite of R1 having a lower med, which is 0. Because neighbor AS is different, so med is ignored. It goes to the next criteria, eBGP preferred over iBGP, so this guy wins. And that goes in the routing table. So again, here I would need router BGP 100, BGP always compare med. So now he will compare the med in spite of the neighbor AS being different. So he should select now iBGP because of lower med. Again, I'm kind of impatient. So now he prefers R1 iBGP over eBGP because of lower med. So you see, med can be a bit tricky. If you want to actually, I believe there's a nice document on this med. If you just search for BGP deterministic med, take the first link. I believe it's the first link, this one. If you take this link, there's a really nice explanation on med, on always compare med with, in fact, there's also deterministic med that you can use to compare. So it gives you, it's just a one-page document. You should read this. It's pretty nice. Just go to google.com and search for BGP deterministic med. All right, so I hope this webinar was informative to you. And now I will answer some questions. I see a question that says, why can't we have values like 0 or 1 instead of 0 and 32768? I really wouldn't know how to answer that because that's how Cisco proprietary weight was designed to have 0 and 32768 as the default. So we probably have to go back to Cisco and ask them why. Why not 0 and 1? But these are the highest is 32768 and the lowest is 0. But 1 to 32767 is configurable and 0 and 32768 is default. Okay, I have another question. How wait and originated linked? I don't understand that question. Are you meaning that how wait and origin is linked? They're not linked, they're completely different. So, or if you're talking about wait and locally originated, then if you have advertised the route by using network statement on your local router, the wait would show as 32768. But on the neighbor router, he's received an update. He would see a wait of 0. That's how they're linked. Okay, then I have another question. Please give me example for wait for path selection of a route. I think we did that as a demonstration. Then I see another question which says, give insight on network versus redistribution. So both are used to advertise a route into BGP. So I could use the network statement to advertise a route in BGP, or I could use the redistribution. As long as you have the route in the routing table, it doesn't mean that it has to be locally connected. As long as you have the route in your routing table, it could be through an IGP. If you receive a route, let's say through EIGRP, if I want to advertise that, I could use the network statement to advertise that, or I could do a redistribution from EIGRP to BGP to advertise the route. The next question that I see is origin is not clear. So origin again is a path selection well-known mandatory attribute. It is transitive. So it could either be I, which is IGP, or it could be incomplete. Why will you see incomplete? If your, let's say if your neighbor is advertising a route to you, and if he has used the redistribute statement, then you would see it as incomplete. But if the neighbor is advertising a route to you using a network statement, in that case, you would see the origin code as I. Okay. And then I see another question. If the AS path is the same, not doing AS path prepend, we can influence incoming traffic path. If there are two border routers and we want one to be preferred as the ingress for traffic destined to our AS, by setting origin to incomplete in the outbound direction on which router. Yes, that is correct. So if you send origin outbound to a neighbor by setting it incomplete, then it affects the neighbor router coming into you. So because I would be preferred. So let's say if you are sending, you have two routers, and just the left router is sending outbound I, and the right router is sending outbound incomplete, then those routers for them to come back to you, they would prefer the left router because I is preferred. So if you send origin outbound, it affects incoming traffic. Okay, and then I see another question, why we have another route from AS 100 now. So I don't really know what context that is for. Okay, so I will answer one more question. I'm trying to look for a good source for regular expressions. So there's a BGP administrator guide. It's a pretty good book. You can just go down from Cisco's website. It has everything. It has even regular expressions. So you could probably have a look at that, or you could look at, I mean, specifically for BGP, you have many books on that. There are many books from Cisco specifically for BGP. If you just want in general, then I have read like TCP/IP Volume 1 and Volume 2 back in the days. But there are lots of books on Cisco's website itself. You just look at the administrator guide or for BGP, it is available on Cisco's website to download. Then I see a question, why med preferred over with local preference for 116? We didn't configure local preference for 116. We only configured local preference for, I believe it was 28.119.16.0 for one specific route. We didn't configure for all the routes. All right, so I hope this BGP Path Selection webinar was informative to you, and thank you for watching.